Kia ora. Let's see for the physics investigation how you can use Excel to draw your graphs for you. So here we've done the distance versus time. I've included the zero uh, points because it takes 0 seconds to move 0 meters. So I've included that even though I hadn't measured that, but that'll help me work out my graph. So if I now go to insert and I look at the scatter, but because I want a curve, I'm going to pick this one. And you can see there's my curve. And so you can see it's sort of like a parabola. So I'm going to be taking the square root. I'm not going to fiddle with the axes titles here in this graph, although obviously you need to make those changes. I'll show you when we do the transform data. So the next step is to take the square root of the distance. And so I've done it here. There's my distance, there's my square root. Now notice how I have included my units each time. So my units for the square root of distance is obviously the square root of meters. So you can either say meters to the half, or you could just simply say a square root of meters. So here I'm going to now include my measured data. So I'm not putting in the 0. And again, I am going to insert my chart, and I'm just going to take the scatter point this time. And now we're going to fix this so it does all the things we want. So you go to the plus column over here. The first thing with the grid lines, we want more grid lines because that way we can see if we're doing a rise over run, there's more chance of the line crossing an exact point, in other words, a vertical and a horizontal line. So we've got that now. Now we actually want to put the trend line in. So we're going to go to the trend line, but you notice it doesn't go through to the y-axis. So we want that. So you click on here, you want a linear one, and then you go to more options. So you've got this. So you want to extend this backwards now. So if this is 0.2, 0.4, 0.5 over here, I mean, if we want to, 0.45 should be fine, but let's just go to 0.5. And you can see it's now been extended across, so you can see where the y-cut is. You can actually also ask it to display the equation on the chart by clicking on this. Now, when we have this, remember this is just simply a mathematical formula. You must change it to a physics formula. So what have we got on the y-axis? What have we got on the x-axis? So hopefully you can see we have time on the x-axis because we've plotted these points. So we need to put in those axes titles. So we click here on axes titles, and this will be time in seconds. And over here, this will be the square root of the distance. So one way of doing it is simply going to insert symbol, and you want the square root. So um, you can just search for the symbol text over here, symbol, and you can hunt for the square root sign. I've just used it, so I'm just going to insert it straight off over there. And so we've got that on there. Oops, close. And now we're going to say square root of distance, and the unit you can, if we want to do that same meters to a half, so we can do meters, and now we can go to home, to font, font, we want a superscript, okay, then we want to insert the symbol of a half, and insert, and now we want to close that, and finally we want to go back because it's still in this. Let me just check if it's still in the superscript. Yes, it is still in superscript. So I'm going to go back here to my font and take off the superscript. So now it should be, hopefully, yes. So otherwise I could have just done a square root. So here we've got now this, so we've got to change this. Y-axis is now time. Our x-axis is the square root of distance. So it's insert symbol square root of distance, and we, oops, we'll keep on closing it, square root of distance, and delete the x. Finally, we give our chart a title, but which you can just say graph showing blah, 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 spell it out. But you've got now a labeled y-axis with with a unit, a labeled x-axis with a unit, and you've got your derived equation where the 1.5656 is your gradient and your y-cut is 0.00669. So that was obviously my reaction time. You can see it's more than 0, and that's because there was a reaction for me to stop the stopwatch, and that's why it went slightly over. Okay, hopefully that helps and shows you how to use an Excel spreadsheet to do the graphs for you. Kia ora.